Welcome back to another lesson on trigonometry. Lately, we've been exploring the law of sines and law of cosines. Today we're about to uncover another interesting result that pops up from the law of cosines. As a quick recap, we've covered the case where two angles and one side length are given. That is, angle, side, angle. We solved this using the law of sines. Then we saw the case where three side lengths are given, side, 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 and used the law of cosines to find the interior angle measures. In the last lesson, we saw two side lengths and an angle, that is, side, angle, side, to solve for the other quantities. Now, we're going to look at side, side, angle. I'll let you use your imagination as to why I did not write this in the opposite order. The law of cosines states that c squared is equal to a squared plus b squared minus 2ab cosine c. So now, plugging in the numbers from my example here, I get 7 squared is equal to 10 squared plus b squared minus 2 times 10 times b cosine of 40 degrees. Notice that my unknown is b, and that 40 degrees is opposite 7. 7 here, 40 degrees here. That's a good check to make just to ensure you're on the right track. Let me expand this out a bit. I get 49 is equal to 100 plus b squared minus 2 times 10 is 20. Cosine 40 degrees is simply a number, and I have my unknown b. I'll plug this into my calculator to get 15.321, and I still have my variable b. Now I'll just fill in the rest. Well, I can subtract 49 from both sides, and that gives me 51 plus b squared minus 15.321b is equal to 0. Have you noticed something here? Well, if I rewrite this, b squared minus 15.321b plus 51 is equal to 0, I have a quadratic equation. I can plug the coefficients 1, negative 15.32, and 51 into the quadratic formula, and that'll spit out my answer for b. Plugging the numbers into the quadratic formula gives me this, 15.321 plus or minus 5.544 divided by 2. Well, what do you notice? That gives us two possible answers, 10.432 or 4.889. Now, why is that? Notice if my triangle as defined here has a small angle at the top, that is, an obtuse angle forms at the bottom here, then the shorter value is going to be our answer. If, however, this hinges out to make an acute angle at the bottom, then the longer side length is going to be our answer. So in this case, we have two possible choices. We are not given enough information as it stands here to answer that question fully. So let's answer it for both cases. Using the law of sines, I've set up the ratio sine A divided by 10 is equal to sine 40 divided by 7. Multiply both sides by 10, and I get sine A is equal to 10 over 7 times sine of 40 degrees. Plug that into my calculator, and I get sine of A is equal to 0.918268. To solve for angle A, I take the inverse sine of both sides. To obtain A is equal to 66.67 degrees. But wait a minute. This angle in the diagram is obtuse, meaning greater than 90 degrees, whereas this answer is acute, less than 90 degrees. Well, what's going on here? This angle corresponds to our longer side length. So what about the shorter side length? Remember from our unit circle and trig identities that the sine of theta is equal to the sine of 180 minus theta. If I had some arbitrary angle in the first quadrant and I reflected it about the y-axis, the height would be the same. That is, the sine would still be the same. So what is 180 minus 66.67? I get A could also be equal to 113.33 degrees. Go ahead, plug this into your calculator. 113.33 sine is 0.91824. Within rounding, that matches up pretty close to what I had here. So we can represent two different cases. Seen here, side length 4.9 matches 67 degrees in this angle. Or if we select the solution for the side length 10.4, then our angle here is 113 degrees. So the moral of the story is, be careful what you're looking at, because you might have more than one answer. For your homework, I'd like you to find the missing angle here and here, one for each case. Now, there's a simple way of doing this, but I'd also like you to incorporate the law of sines and see what you discover. Let me know in the comment section below. If you enjoyed this video, please like it and subscribe to my channel to get more videos like this in the future. Thanks for watching, and I look forward to seeing you next time.